Hey everybody, for section 4.2, we're going to start graphing points by plotting them and looking at their intercepts. And intercepts is, that word sounds like intersect, which it's the same thing as. It's basically a synonym for intersect. So a y-intercept is where the line crosses the y-axis, where it intersects the y-axis. The x-intercept is where the line intersects the x-axis. Now I have the property here of the solution of linear equations. And what I wrote is that if an x and a y is given in an equation, you'll have an equation and there's both an x and a y in it. You're guaranteed that the graph of the equation, when we draw the line of it, whatever the line might be, whether it looks like that, it could look like anything really, but whatever the line looks like, it will have exactly one x-intercept. It's going to have one x-intercept. Pardon me. It's going to have one x-intercept like right here, and it's going to have one y-intercept like right there. All right, and that's a given. If there's an x and a y in an equation, those two things will hold true for sure. All right. So for example 1 here, we're just going to practice graphing this. For example 1, we don't have any x values. We don't have any y values. So what we have to do is we have to just make up some values for what the x could be. And, 0 is a good number. I would always go with 3 numbers or 3 ordered pairs. We should put it that way. We should have 3 ordered pairs. I'm going to start with 0 and kind of see where that takes us. So I'm going to put in 0 for x as our independent variable. And, we totally made that up. I mean, I just pulled 0 out of thin air. But that doesn't mean we can do the same thing for the y. We can't just say, well, 0 is the x, and I'm going to make 17y. And if I make x 4, I'm going to make this one 25. We can't just make all those numbers up. But we can make up the independent variable. And then the dependent variable, just by the name that's given, dependent, it's going to depend on the x. So we're going to put in that value for x. So 2 times 0 is 0, and so that's just going to be y equals -3. So that's right there. All right, and then let's go ahead and put in another number. Let's say we're going to put in, let's say we put in 1 this time. So we put in 1, so we're going to do 2 times x plus y equals -3. Put a 1 right there. So 2 times 1 is 2. Then take away -2 from both sides, and we get y equals -5. And then just to switch things up a little bit, I'm going to use -1 for an independent variable. So we're going to put in -1 this time. So 2 times -1 is -2. We got -2 plus y equals -3. And then just add 2 to -3, and then you get y equals -1. So let's go ahead and confirm that by graphing it. So we got 0, -3. 0, -3 is going to be right here. That's where 0, -3 is going to be. And then we've got 1, -5. And that's going to be right about there. And now we can tell that it's kind of following this progression. I'm not being very neat on purpose, but the third point should be somewhere around there. And now the third point, we've got -1, -1, and there it is. So right there is right there is your x-intercept, and right there is your y-intercept. So that equation had an x and a y in it, and it's guaranteed to go through the x and the y axis at one point, not more than one point. If it goes through at more than one point, it's not linear. All right, for number 2, I'm going to go ahead and just make up some values. So I'm going to put in a 0 for x. So we've got x minus this equals 4. And if we put a 0 in here, that is just 0. So you got -3y equals 4 divided by -3. And then that equals -1 1/3. I'm going to change that to a mixed number. And now what I'm going to do is this time, I'm going to use the y as the independent variable. So I'm going to do x minus 3 times what equals 4. And I want to think about this because I want the graph, I want it to work. And let's say we make it -2. Then we make it -2, and so now we rewrite it. You got x plus 6 equals 4, because you have -2 times -3 right here. And then take away 6 from both sides, and then we get x equals -2. There you go. So using -2 wasn't a bad choice, and I used that for my y. And it's okay to use an independent variable either way, just as long as you make the other variable the dependent variable. So this time around, I put a -2 and I got out -2. That happens. You get in, you put in the same thing you get out. That's going to happen. All right, I'm going to do the same thing for the third point. Let's go ahead and let's do -1. X, so I'm going to use -1 there. So x minus 3 times -1 equals 4. And you got x plus 3 equals 4. Take away 3 from both sides, and you get x equals 1. X equals 1. So 0 and -1 1/3 is going to be, here's 0, -1 1/3. It's going to be like right about there. Kind of eyeballing that one. I'm not exactly sure it's right there perfectly, but it's probably pretty close. We've got 2 -2. Oops, wrong place. 2 -2s right there. And then we have one -1. So we have 1 -1, which is right about there. And those points look like they're collinear, meaning they're part of the same line. Now, if you end up graphing some points and you have some errant points, like you have a point here, you have a point here, and you have some points that are kind of like, they don't seem to make, even if you were to connect all the dots there, they wouldn't make a line, then something's up with your points. And it might not be just the errant dots, it might be the dots you started off with. And you might want to go back and reevaluate what you did, okay? So when it comes to finding the x-intercept and the y-intercept, what it's a matter of doing is it's a matter of putting in zeros, okay? Now you have to put a 0 in for the right value. So when it comes to the x-intercept, you want to put a 0 in for the y. So you kind of want to make that your independent variable. And then once you put that in, when you plug that in, see what comes out for the x. That will be your intercept. That's where it will intersect the x-axis. All right, when it comes to the y-intercept, when it comes to that, we're going to use 0 for the x value as the independent variable. And then we're going to see what that turns the y into. And that will be your y-intercept, meaning that's where it's going to intersect the x or the y-axis. All right, so for example number 3 right here, we've got graph y equals -1/2 x plus 3 by finding the intercepts. Let's do this, all right, and it says one other point. So let's find the intercepts first. So let's do 0 here and 0 for the y. And when we do that, we got -1/2 times x plus 3. And we're going to use 0 and see how that comes out. Now 0 times anything is just 0. It's really easy to put in zeros as your variable because they just kind of cancel something, whatever is with it, out, unless you're adding. But you got 0 plus 3 equals 3. So 0, 3 is your y-intercept. 0, 3, right there. All right, now let's put it in 0 for the y. We're going to do -1/2 plus 3 equals 0. All right, so we're going to take away 3 from both sides. Take away 3. I forgot the x, didn't I? Got the x. Should have put an x right there. So you got -1/2 x equals -3. And then when you have a fraction next to a letter, what you want to do is you want to flip the fraction and then multiply it on both sides. So the reciprocal of -1/2 is -2. I mean, you can put it over 1 if you want, but it's just -2. So times -2. those cancel on that side, and then you get x equals 6, because you have negative 3 times negative 2. Negative times a negative is positive. So you got 6, 0, 6, 0, which is off the graph, but I would guess it's right around here, like in that vicinity, like right around there. And so we know that our graph, for the most part, I would suggest using 3 points for a graph, which is what we're doing still, but we have a general idea of what our graph should look like. The line of our graph, so it looks like that. So we know that there's a point. We know that there's a point somewhere in here, and we can get that point by using one of the x values down here. So using 2, 3, 4. And what I'm going to do is I'm going to use 2 because that multiplies by 1/2 nicely. I'll make some room here. I'm going to use 2. So you got negative 1/2 times 2 plus 3. And then negative 1/2 times 2 is negative 1. Negative 1 plus 3 is 2. And that seems to work. I mean, I know I didn't draw this perfectly, but yeah, it's in that ballpark area right there. You got 2. All right, for number 4, we're going to graph x plus y equals 0. And we're going to use a 0 for the x, a 0 for the y, and then we'll determine that third x or y after we're done with these 2 points. We're going to do 0 plus y equals 0. And then 0 plus y, that's just going to be y equals 0. And the same thing is going to happen for this. So that's very unhelpful because both the points are at the origin. So it intercepts the origin, which, it does intercept the x-axis and the y-axis, but when it doesn't intersect it at different points, which makes it hard to tell what the graph looks like. So we're going to have to make some other points. So let's say we make, let's make a couple. Let's say we do negative 1. So we've got negative 1 plus y equals 0. And then I'm going to add 1 to both sides. And what's that give us? That gives us y equals 1. So you got negative 1, 1, which is right there. And there's your line. Goes like that. Now, the thing I want to point out on number 5 and number 6 is that you got to watch out for these equations. Now, number 5 is a y only, and I think I mentioned this, or number 5 is an x only equation. And I think I mentioned this in a previous lesson, perhaps. But when it's an x only equation, it's going to be a vertical line, meaning it's not going to go through the y-axis. If it's perfectly vertical, if it's perfectly vertical like this, if it's perfectly vertical, like right here, it goes through negative 4 on the x-axis. Doesn't go through any y's. Right here, it goes through negative 3 on the x-axis. Right here, it goes through positive 2, goes through positive 3. I mean, right here, it goes through 0 on the x-axis, and it goes through every single point on the y-axis, which causes some trouble. But it's, for this particular one, it's going to look like this. It's going to be a vertical line going through 3. So you can make up any value for y. We could put in 0, we could put in 1, we could put in 2. All those values are perfectly fine and well suited for that line. Now, when it comes to a y-only graph, that is going to be a horizontal line, a line that goes left to right, straight from left to right. That's going to be a horizontal line. So if it's a horizontal line, it's going to be just like this. And notice that this goes through the y at 3, this goes at 2. Right here, this would be negative 1. That's the actual graph for it. But notice it does not go through the x-axis, unless it goes through the origin. And if it goes through the origin, it goes through every single x, which is a whole different thing. But yeah, right here, horizontal, this is x equals negative 3. This is x equals 4. This is x equals 0. This is x equals negative 5. So if it's just an x, or if it's just a y-only equation, it's going to look like that. And so if we make some points for this one, we can just make negative 1 for y, and you can use any value you want. Any number you want to use is viable does not matter. All right, for number 7, the average annual cost of college tuition and fees at a private 4-year institution could be modeled by that equation, where x is years after 2013 and y is the cost of tuition in fees and dollars. So question A says find the y-intercept of the graph of this equation, meaning we want to put a 0 where? Where do we want to put a 0? For the x. That's what we want to do. So we're going to write out that equation, 1172.50 times x plus 24,909. We're going to put a 0 right there. Now 0 makes 0 when you multiply. So you got 0 plus 24,909, which equals, that's it, $24,909. All right, and it says explain its meaning. So since we put a 0 in for the x, and x is the number of years after 2013, what that means is that's the price in 2015, or 2013. That's the price in 2013. Because we put 0 for 0 years after 2013. So 0 years after 2013 is 2013. All right, find the approximate cost of tuition and fees in 2022 and 2023. I'm going to use 2023 because that's exactly 10 years. At least in this, not that, let's use this one, sorry, 2022, because that's exactly 10 years after. Let's go ahead for B, find the approximate cost of tuition and fees in 2022 and 2023. So I'm going to do 2023 because that's exactly 10 years after 2013. And 10 is a nice number to use. So $1,172.50 times x plus 24,909. I'm going to put a 10 there because it's 10 years after 2013. And multiplying by 10 is just a matter of moving the decimal over. All right, so now it's $11,725 plus 24,909. And now add those up. So now there you go. So it's around $36,000, $36,634 to be exact, around that.